All right, this is section 6.6, and it's video number 2. We're going to continue solving exponential equations using logs. Here's an example where we have two different exponents, base 7 on the left and base 3 on the right. We're still going to just take logs of either side. You could use natural log or you can use log base 10. It'll work out the same in the long run. I'm going to use log base 10. Log of 7 to the 2w plus 1 equals log of 3 to the w plus 2. Using my exponent property, this becomes 2w plus 1 times log 7 equals w plus 2 times log 3. And be sure to use your parentheses there so you make sure you're multiplying all 2w plus 1 times log of 7. All right, remember log 7 and log 3, which I promised to use parentheses and I've been forgetting, are just numbers. If it was just 7, you would multiply 7 through by 2w plus 1 and then get all the w's to one side and all the numbers to the other. We're going to proceed exactly the same way, remembering that log of 7 is just a number. So we're going to distribute it through. It's 2 times log 7 times w plus 1 times log 7, which is just log of 7. Likewise with the log 3. Log of 3 is my coefficient on w plus 2 times log 3. All right, I'm going to get the terms with w on one side and the terms without w on the other side. So I'm going to subtract log 3 times w from each side. And I'm going to subtract log 7 times each side. This becomes 2 log 7 times w minus log 3 times w on the left-hand side. And because these canceled and these canceled, the right-hand side becomes 2 log 3 minus log 7. All right, let's keep going. How do we get those w's by themselves? Well, we're going to factor them out. W, what would be left behind is 2 log of 7 minus log of 3 equals 2 log of 3 minus log of 7. And we're going to divide this off. If this was w times 5, we divide by 5. It's w times some number, maybe written in a long, complicated way, but it's still just a number that we're going to divide off. 2 log 7 minus log 3. And my final official answer, my final exact answer is 2 log 3 minus log 7 over 2 log 7 minus log 3. All right, that's my exact answer. If you wanted to use properties of logs to simplify this, you could. I'm just going to leave it like that. And then what I'm going to do as my final step is I'm going to do a decimal approximation to check my answer. All right, let's do a decimal approximation to check an answer. What is w about equal to? Let's use our calculators to find out. So 2 log 3 minus log 7. For the numerator, I get 0.1091. For the denominator, I get 2 log 7 minus log 3, and that gives me 1.213. I'm going to divide those guys. 0.1091 divided by 1.213 gives me about 0.0899. All right? Let's go up and check these answers. So the original equation is 7 to the 2.0899. 2w plus 1. Is this equal to 3 to the w plus 2? That's our check. All right, let's put this into my calculator. 7 to the 2 times 0.0899 plus 1 turns out to be about 9.932. Let's take 3 to the 0.0899 plus 2, and I get 9.934, but that's close enough since I was rounding using decimal approximations anyway, so I feel good about my answer there. Let's try another one of these problems. All right, sometimes they're a little bit more complicated, and they have coefficients in front of the exponential part. The key is to isolate the exponent first. All right, so let's go ahead and solve this problem. And the first thing we're going to do is isolate the exponent. So we're going to divide both sides by 4, and that gives me 3 to the 1.07 to the t equals 1.06 to the t. Now I'm going to divide both sides by 1.07 to the t, so I can get one exponent. Left-hand side becomes 3, and the right-hand side, well, I have base 1.06 to the t, and I have another base 1.07 to the t, so this can be the ratio 1.06 over 1.07 to the t using a property of exponents. Now I can take logs of both sides. I've been using log base 10. Let's use natural log on this one. The natural log of 3 equals the natural log of 1.06 over 1.07 to the t. Using the exponent, that brings the t out front. So the natural log of 3 equals t times the natural log 1.06 over 1.07. So we're going to divide both sides by that natural log of 1.06 over 1.07. And my final answer is t equals the natural log of 3 divided by the natural log of 1.06 over 1.07. And that is actually how I would leave my final answer. Let's go ahead and check this guy using a decimal approximation. Using our calculators, let's see if we can squeeze it in up here. T is about equal to, so this is my check, natural log of 3 divided by natural log of 1.06 divided by 1.07. And I get negative, really close to negative 117. All right, so let's check the left-hand side. 12 times 1.07 to the negative 117 is about 0.00438. And 4 times 1.06 to the negative 117 is about 0.00438. Great, that's a 0. Awesome, so this checks out, and we did this problem correctly. Let's try one more example. All right, what are we going to do on this one? Well, the first thing we're going to do is divide each side by negative 2. And that gives me 3 to the 5x equals negative 9. Well, right here, I should start to think something's fishy, but let's keep plugging along in our normal way. Let's take logs of both sides. Log of 3 to the 5x equals log of negative 9. All right, anybody see a problem right here? We can't take the log of a negative number, right? You cannot take the log of a negative number. So right off the bat, this does not exist. Does not exist. Backing up, we should have noticed right here that something was weird. Because if we take 3 to a power, how are we going to get to negative 9? The domain on exponential functions is 0 to infinity. So we could not possibly come up with a negative value. So this one has no solutions. Always be on the lookout to take the log of a number less than or equal to 0. Has no solutions. All right, I think I have one more example. Oh, nope, that's the last example for this video.